Top of the morning, everyone. Let me greet you all. Thanks for joining my channel today. My name is Benjamin Malunda, and I welcome you all to my channel, Learn a Lot. So today we are going to start a new series on image classification. We're going to use eCognition as our software. So we're going to run an object-based image classification. So for this specific tutorial, we're just going to focus a bit on how we can import data into eCognition and how we can view different veins and just do a few things to prepare ourselves for the next tutorial where we are going to start our image bake. So our tutorial will be split in 4 sessions. The first session, which is this one, will be on how to load data and how to explore our dataset in eCognition. The second part of this tutorial or this session or these classes will be how to extract water features when you're doing image-based classification. So we're going to run a full image classification, but we're going to split the tutorials on how to extract each specific classes. So the first one will be, we'll deal with vegetation. The second one will look into vegetation. The third one will look into base soil, and so on and so forth. So hopefully you will learn something from this tutorial. Please like and share and subscribe to my channel as well. And know that if you need any kind of assistance, you can always leave a comment in the comment section asking for a specific tutorial within a specific software, and I'll be happy to upload it for you. So without wasting much of your time, let's get physical. Okay, that was uncalled for. So let's get started. Okay, so this is my eCognition already opened on my computer. So on the top section here we have various different options like navigation options. That option there is to open a project. If you want to open a previous project that you've been working on eCognition, if you want to create a new project, that's the button you go for. And then there are these panes that we are going to discuss further once we have loaded our data. But this dark area where it's written eCognition developer, that's where your data will be displayed. So let's go ahead and load our data. For the purpose of this tutorial, okay, I do not know why this thing decided to show up on the other screen. For the purpose of this tutorial, we will be using Sentinel data. I have downloaded Sentinel data of a specific area in South Africa, in the Oksburg area, inclusive of the Cat River Dam, which is somewhere around in the towards Simo. So from the Sentinel image, I only selected few bands that I really needed. I selected the TCI band, which is a 3-band composite, true color composite image, which is the one I'm going to classify. And then I also took band 8, band 4, and band 3, because to run the classification, I'm going to need to compute NDWI, which is the normalized water index, and also the normalized vegetation index that I'm going to use for classification as additional inputs for classification. You can actually look at other inputs such as your elevation data and all that to make sure your classification runs smoothly, but for the purpose of these sessions, I'm going to use these 3 images, and I'm going to compute NDVI and NDWI to help with the classification. So to start with, I'm going to load all my 4 bands. As you can see here, it shows you the most active band, or the band that you selected. There you go. There you go. So we've got about 4 bands that we're going to select, and then we're going to click OK. When you click OK, sorry, this is important, we need to view it here. So this is the create project tool that you're going to look at. So we're going to rename our project as object based classification, or you can give it a different name. So I'm going to call it OGSpec to specify the area where I'm running my classification in. And in the following section, you've got the images descriptions, like your resolutions and your projections and the extent of your image and all that. And the pixel size is in units, it's in auto, it's in meters, I mean. You leave the rest as they are, you don't have to do anything. So if in any case you uploaded an image with a greater extent and you want to subset it, you can always click on the subset section, and then it will allow you subset the image to the area that you want to focus in. But for the purpose of this tutorial, we do not want to extract just a single section. We want to use the entire image. So I'm going to go ahead and cancel that. Next, what you need to do is rename your layers, right? So for example, this layer here is Ben 3. Ben 3, I think Ben 3, when you're looking at, sorry, I'm just going to do this, sorry. That's layer 3, that's Ben 8, I think. I'm going to edit that and call it near infrared. Ben 4, that's the red band, I think, if I'm not mistaken. And then Ben 3, that's the blue band. That's the blue band. And then these are the three layers that make up the TCI layer. You can leave them as they are, or you can actually rename them, but I'm just gonna leave them as they are. Or let me just no, it's fine. Let me leave them as they are, because it's gonna get a bit complicated if we try and make a lot of renamings. What the hell? Let's just rename it. So I'm gonna call this TCIB blue, and then I'm gonna call that. You don't need to rename this one, but it's fine. I'm gonna call it TCI green, and then I'm gonna call this TCI red. Then I'm gonna click OK, because we are ready now. So OK, then our data is gonna load. There we go. So we've got our data that has loaded. As you can see, it has loaded in a false color composite, and we can now start looking at how we can actually manipulate these color composites in order to view our data. So if you want to change color composite or manipulate your band combinations, you have the options that is there. And as you can see, it has selected the first three bands, the blue, the red, and the near infrared bands. But these are not the ones that we want to view really. We want to view the true color composites that we have here. There you go. So now we can see the true color composite, because vegetation appears as green, and then you've got base soil there, you've got some farmlands on this side, and you've got shallow water that appears really dark there. This is shallow water. I think it's swamped into vegetation. It's vegetation swamped into water, but I think, yeah. And then you've got the Cat River Dam that appears there. So if you want to do a false color composite, we can add the near infrared, the red band, and the blue band, right? Oh, sorry, this has to be red. There you go. That's the false color composite, where your water body goes blue, and this is deep water body. It appears blue for some reason. It's creepy, and then you've got red vegetation. I mean, you've got a bit of a shallow water body there. So that's about it. So if you want to manipulate your band combinations, you can always do that here. So when you're doing your band combinations, it allows you to separate between different features and know, for example, here this is wet soil, all right, because that's a shape of the wetland. The whole area, there is a wetland here, and this is commercial forest that we are looking at right now here. And so that's wet soil that appears a bit darker. It's not water. So those are things that we need to look at. These are shades, because this is a mountainous area. That's a bit of shades that we have there, or shadow. What I mean, I don't know what I'm talking about when I say shade. And then you've got your built-up area. So you can do your band combination in order to actually highlight certain features when you're doing your calculations or your classification. I mean, so okay, I'm gonna say okay. Right, so now talking about the panes that we're looking at, the first one, the first pane that we have here, this is what we call the process tree. That's where you build your actual process for classification when you want to classify an image using objects methods. So it's where you build your rule set. We call them rule set when you're dealing with eCognition. So that's where you build your rule set and what you tell your computer on what to do and what you want to classify an image. Class hierarchy, that's where you all your classes. So when you're building your rule set, you're gonna tell the computer that for this kind of rule set, I want it to produce water for me, water classes for me. So it's gonna produce water classes and store here the class that you have produced. So if you add another class like vegetation, it's gonna be they're all gonna be listed here, the classifications that you're gonna use. This object information is gonna display all the information that you need. So you need to specify that in this tree here, for example, and say, let's say select features to display. Let's say we wanna look at the layers, the mean value of our near infrared, our brightness, and our brightness value. Let's use those two, near infrared and brightness value, right? Those are the information that will be displayed here every time you click on your map. It's gonna tell you, okay, this is the information you need for your class, or this is what the class is saying about NDVI, or sorry, your vegetation, when you click on vegetation and all that. But that, I think it's going to be active the moment you finish, the moment you run your first merged classes. Feature 3, that's where you have a list of different options that you can use through your classification. So you're gonna see how this can be used as we are moving along. So for example, if I double click on NDVI, there it gives me an opportunity here. You've got what you call this. These are bars that gives you a scale of ranges of values. So when you're doing a classification, you can actually put thresholds there to see NDVI values or near infrared values for vegetation, from what values to what values, if you want to separate your spectral mixtures. So this is about it. If for what you want to know, for example, I'm gonna just try and say let's append new. So this will be like my parent class or my parent process. I'm going to call it classification, and I'm going to say execute child process, and I'm going to leave it as is. And then I'm going to create a child process. In the child process, I'm going to look for segmentation. Where is segmentation? I'm going to segment I think we're going to use a pixel level, since we do not have anything yet. Oh, sorry, I didn't select algorithm multi-resolution segmentation. Sorry about that. I did not select. I clicked on segmentation. Sorry. Yeah, multi-level segmentation. So we're gonna run this from parent, and then this, I'm gonna call this level one. Level one. Because it's the first classification we're running, so it's just going to look at the pixel differences and then run a classification from it and creates more like creating an object layer for me. So I'm going to use that object layer to start running the classification. So here, image layer weights, so you give certain weights to certain layers that you imported into your software, and those layers are supposed to so specific layers of specific information that they highlight. For example, the near infrared is very good at highlighting vegetation and water bodies as well. So you can give more weights to the layer. I'm going to give it a 2. So, sorry, when it creating spectral mixtures or special objects for me, it's going to use near infrared more, and then we're going to say the scale parameter. I think I'm going to leave it as that, but the shape I'm going to put it to 2 because the shape defines how the spectral objects are created. And then compactness, for example, if you look at water bodies, they tend to be more compacted than other features. For example, a settlement, you have houses scattered all over the place, but you cannot have water bodies with water scattered all over the place. Water is compacted, so we're going to give more weight to compactness as well, so that our data is classified appropriately. So uh, uh, yeah, let's execute. Well, this whole thing is just preliminary. We're gonna start running the appropriate process in the next tutorial. For this, I just want to show you how the compactness are shown and how we can use this object to, sorry, this image object information pane to start identifying class differences and things like that. Okay, so there is our segmentation. It's quite a lot of segmentation that happen. There's way too many segmentation that happen. No wonder it took a bit of time. As you can see here, it tells you that your segmentation process took about 1 minute 55 seconds and some 90 something milliseconds. But well, the segmentation happened, as you can see now. So we have our water body, for example, here with the segmentation. We selected near infrared and brightness to be part of the information criteria that we want to use. So there you go. So it shows you that the near infrared value for that water body is about that much, right? And the brightness is about that much. If you click on another one, it's gonna show you a bit different values for each of them. So that's where the what you call this, the threshold boxes come in handy, because now it starts telling you on how or which values you can use for segmentation of your near infrared. So if I click on that and say, let's say until 400, let's see, there we go. So you see between 0 and 400, those are the pixels that have been selected. If we increase that to, let's say 600, aha, so you see just above 600, you've got many other features that are selected as well, but the entire water body is selected. So you can say near infrared values below 600 should be assigned to water bodies, but that should not be all, because now we've got other features that are also assigned to that kind of brightness or that kind of near infrared value. So we need to add additional layers. That's what we need, things like your NDVI and things like that, because they help calibrate our classification when we're doing object-based classification. I don't know why it's saying 0 there. It's supposed to be 0. Yay. So let's say 500. Some features I've left. So 500 should be a good value for us to say this is what a water body. If we zoom it to extend, let's check the other water body and see what is there. If we zoom into the other water body, yeah. So because this water body is a bit shallow, we would expect their brightness to be higher. You see, sorry, okay, it's not that high. So why are we looking at this? For something. Yeah, infrared is between 0 and 4 something. Also, oh no, sorry, I'm the one who's wrong here. It's selected already. Or is that 1,000 and some odd? No, it's not 1,000 and some odd. That's 1 and something. But as well, you see, those are different issues now you're gonna meet when you're doing image classification object-based. So you need as much layers that you need to make sure you're putting differences amongst your spectral differences. So that's all for today. See you on the next video, where we're gonna actually start looking into doing the actual proper image segmentation and doing object-based classification. For the next tutorial, we're gonna look at specifically how we can classify water features. So stick around until we're done with the whole tutorial. Until then, this was your boy Benjamin from Learn a Lot. Thanks for watching this video. Press subscribe and hit that bell so that every time I upload a video, you are notified and you can watch more of my videos. Don't forget to comment. Thanks and ciao. Keep safe.